Okay, polynomial functions. I'm going to show you a method of graphing polynomial functions using what I made up myself called the Algebraic-Polynomial, function man, or I call for short the ABF man, the APF man. And basically he looks like this. First you have your arms here. And then after you know your arms, you have something called I call it the teapot, and then there's the head. Okay, so it works like this. Step one, the first step is you look for the arms. All right, and your arms represent the end behavior of the polynomial function. You have to memorize these steps. So first you do your arms, right? And the second step is after you know your arms, you look toward understanding the turning points, or what I dub as the teapot, because if you look at it carefully, it does look like a teapot. This is the handle, that's the spout, and you can pick it up and turn the teapot. So there's a teapot, and this is I always mark n-1 inside the teapot, and it is turning point, teapot, turning points, or turning points. And the third step, after we have our arms, after we have a teapot, is to look into the face, the face intercept, or face multiplicity. Okay, face multiplicity. And usually when I look at the face multiplicity, I determine whether or not an x-intercept is crossing over the x-axis, or it's touching and turning around like that. Okay, let's start with step one. Okay, whoops, sorry. Now, before you can start graphing a polynomial function, you have to know what a polynomial function is not. A polynomial function does not look like this. So if you see this, this is not a polynomial function. Okay, guys? Okay, x plus 1. That's not a polynomial function. This is not a polynomial function. Okay, that's not a polynomial function. Another thing, that's not a polynomial function. So you can see polynomial function does not have negative exponents and doesn't have fractional exponents. Polynomial functions have positive integers. Polynomial functions have positive integers. Okay, as the power. For example, n will be equal to a positive integer like a 2 or 4 or 6 or 3, right? Only positive integers. Okay, that's what polynomial functions are not. They only have positive integers. Okay. Now that you know what they're not, we can move on to kind of describing what polynomial functions look like. Polynomial functions, when you're graphing polynomial functions, they're always smooth and curvy like this. Okay. See that? Another thing about polynomial functions is that when you're drawing them or when you see them, they don't have jagged edges like this. Okay, it's wrong. It's not a polynomial function. Right? Another thing about polynomial functions is that when you graph them, since they're smooth and curvy, they don't jump to another spot. They don't jump. Okay. Some graphs are like this though. Right? That's not what a polynomial function is like. They're always smooth and curvy like this. Always curvy like that. Okay. And you can draw the polynomial functions without taking your pen off the paper. The moment you can take your pen off the paper like this and draw and keep drawing a function like that, it's not a polynomial function. That's a rule of thumb. Now, let's start off with the arms. When you want to graph the polynomial function, right? When you're graphing the polynomial function, the first thing you want to do is start out with the step one is to graph the arms. Find out what the arms are. The end behavior. And we can determine the end behavior of a polynomial function like this. Let's say you have this function. A represents some number, right? Some number x to the nth power. The n can represent anything. It can represent 3. It can represent 4. It can represent any positive integer. Right? Not a half, not a minus, but a positive integer. So let's say n represents a positive integer. Okay. Now, in order to determine what the arms look like, here's how it works. If the highest exponent of the polynomial function, right? If the highest exponent of a polynomial function is an even exponent, for example, let's say it's x to the 16th power, right? It's even. And the function is positive. So if the highest exponent is even, like let's say for example 16, right? I don't want to mess with my pen, and it's positive, then on a graph, the end behavior would be up, right? It's gonna be in the upper quadrant, and it also will be in the upper quadrant of 1. So it will be both in quadrant 2 and quadrant 1. So it will be up, right? This is some students get confused when I say up and down. So this is up. This is the up section of a quadrant. This is quadrant 3. This is the down area. Okay, it's below quadrant 2, so it's down. This quadrant 4 also is down. Okay, so it's gonna be when it's even, when it's the highest power is even and it's positive. It's a positive. The whole thing is positive. It's going to be up in this area. It's going to start here and it's going to end here. It's going to start up left and up right. Okay. Now, let's move this out of the way. If it is even, if it is even power and it is negative, then it's going to be facing. Then it's going to start down left and it's going to end down left. Okay. Got it? Okay. Now, if the power is odd, like 15, or the highest power is odd, let's make these smaller, like 9 or 13, doesn't matter as long as it's odd, then it's gonna be facing, it's gonna start down left, right? It's gonna start here down and it's going to end up. So down, left, up, right. Okay? Now, if it is odd and the function is negative, then the arms are going to flip. Okay? So this time is going to start. We always read the graph from left to right. Remember that. So it's going to start from up left in quadrant 2, up, and it's going to end down in quadrant 4. So up left, down right. Okay? Okay, so once you figure out whether or not the arms are even or odd, right, and if the function is negative, the next step is determine the teapot. But before we go there, I want you guys to get some practice. So determine the end behavior of this function here. F of x equals to 2x 6 plus 3x 1, right, plus 2. What will the end behavior of this, what will the arms of this function be? Right? We can either, here's some options. We can either have up left, right? Up. Right, these are quadrants. Quadrant 2, right? Quadrant 1. We can also have down left, down right, right? Another one, we can have down, up. Another one, up left, down right. So if we look at this function, the first thing we're going to look at is the power, right? The highest power is 6. 6 is even or odd. 6 is even. And if it's even, like I said before, we're going to have it up. It's going to be facing up. And also, it's positive. So indeed, it will be facing up left, up right. Okay, now let's change it. What if the function, what if this function was f of x equals to x half plus 30x 2/3. Well, this function doesn't exist because remember, polynomial functions have to have a positive integer. They can't be half powers. Okay, let's try another one. What about this one? Negative 3x to the negative third minus 2x squared. 2x negative squared minus 21. Let's say these one. This is not also not a polynomial function. We're not going to graph it. Not going to worry about it. Right? We're only concerned about polynomial functions. What if we get this one? Negative 5x squared plus 15x plus 1. Okay. Well, which way will this graph be facing? Well, look, the highest power is 2 is even, right? And look, there's a negative in front of it, the whole function. So it's going to be facing down. It's going to start down, and it's going to end down. Down left, down right. Okay? Well, what if this power was to the 5th power? Well, initially we know that if it's odd, I mean, if it's to the 5th power, the highest power is 5, then it's gonna be odd, and odd is gonna be down up, but because there's a negative in front of it, it's gonna be starting up left, down right. Okay, so here's another one. One more. How about this? F of x is equal to x plus 3 to this fourth power x minus 8 to the third power. Well, we've got to determine the end behavior of this function. Well, if you go back to powers, what you have to do in order to determine this is to add the exponents together. So first you will look at the 3. 3 times invisible 1 here is 3. There's 3. All right, hold that thought. 4 times 1 is 4. Okay. Add the exponents. 4 plus 3 is 7. The highest power of this function would be 7, which is odd, right? It's odd. So we know that the function is the highest power will be 7 because we just counted it out. And look, it's positive, ain't it? It's positive. So it will be odd, and it will be, therefore, since it's odd, it's gonna be a down left, starting down left and ending up right. Down left, up right. Good. Okay. If it was negative, then it will be the opposite. If it was negative, up left, down right. Now, that's the first step, your arms. Your next step, after you have known your arms, after you know where your arms are, you gotta get your teapot, right? Your teapot. His hat. That's his hat, okay? And teapot's equal to n minus 1. That is, teapot's equal to ax. Let's say this was the power was 15, right? Well, let's make 15, right? The teapot will be this highest power number, right? Which will be n minus 1. Okay. And in this case, our teapot, our turning point, would be equal to 15 minus 1 equals to 14. This function here, x to the 15, some number x to the 15th power f of x would have up to 14 turning points. It doesn't have to have 14 turning points, but it will have up to 14 turning points. Okay. And basically, what are turning points? Teapots or turning points. Teapots. Turning points. Turning points basically show us how many times a graph turns around. Okay? These are the turning points here. It tells us how many times it turns around. Okay. In this case, there's 4 turning points. 1, 2, 3, 4. Here's a question: if this graph has 4 turning points, how many? What's the highest power of the graph? Well, you can work your way backwards. Since turning points is n minus 1, right? And if n minus 1 equals to 1, 2, 3, 4, 4 turning points, 4 turning points, then n should be equal to 5. Let's prove it. N equals to 5. Okay, that will cross out. N will equal to 5. See? 5. So the highest power will be 5. And this function should be odd. And since it's facing this way, it will be a negative function, right? Because we have up, left, down, right. That will be odd function. Negative function that's odd. Right. Now your next step after you've determined your teapot, is you gotta know what's inside your face. How does your function behave? How does he feel? Does he feel happy? Does he feel sad? Does he feel strange? Right? And this involves the determining what I call this step, this third step. I call this step the face step, the face multiplicity step. It involves determining how repetitive the x-intercepts are. Right? It involves the x-intercepts. And sometimes books give the face multiplicity, or the x-intercepts nicknames like zeros, okay? Zeros, critical values. Sometimes they give the name roots. I like to call them magnets. Magnets. Okay, because when you draw them, it's as though you're touching magnets. Right? They're attracted to each other. So let's look at this function here. The term to determine its face multiplicity. Let's look at one. How about this one? 2x to the fourth power minus 8x squared. Now, when you're determining the face multiplicity, we're determining or finding each real zero and its multiplicity. I'll explain to you what multiplicity is later. And then we're going to see if the graph crosses the x-axis or touches or turns around at the x-axis. Okay, so let's find the face multiplicity of this function here. F of x equals to 2x to the fourth power minus 8x squared. Now, the first thing we got to do in order to determine the face multiplicity, right, or its repetitiveness, is to factor. So we're going to factor this. So this becomes, when we factor, it becomes 2x squared minus 4. And we can factor this more. We have more space here. 2x squared x minus 2x plus 2. Okay. Now that's factored. What we're going to do now is solve for 0. Take all these factors, solve for x. Sorry, it's not solve for 0, solve for x. Okay. Set them equal to x. So 2x squared equals to 0. Right? X minus 2 equals to 0. And then x plus 2 equals to 0. If you solve for x, you divide the 2 out, right, on both sides. Right? This becomes x squared plus or minus 0. And it will be equal to x is equal to 0. Good. And this one will be equal to x is equal to positive 2. All right. Something I forgot. After we solve for x, we got to look back up at this thing here. The power that we got from here. I mean the x that we got from here. Its power is 2. So it's repeated how many times? This x equals 0 is repeated how many times? Twice, right? So we call this x, the root of x, or 0 of x is equal to 0, and it's repeated twice. This repetition is called its multiplicity. When it's repeated twice, it's called its multiplicity. So this is how we phrase it. X equals to 0 of multiplicity 2. I'm telling you that it's repeated twice, but in your textbook and for tests and for our mathematical purposes, they express it this way: x equals to 0 of multiplicity 2. Okay, look at this one. X minus 2 equals to 0. Solve for x. X equals to 2. What's the multiplicity? There's an invisible 1 here, right? It's not 2, it's an invisible 1. It's of multiplicity. It's repeated how many times? 1 time, right? 1 time. Of multiplicity 1. Right? And this one, x equals x plus 2. Set it equal to 0. X plus 2 it will be x minus 2. What's the multiplicity? There's an invisible 1 here, right? X minus 2. So it's of multiplicity 1. Now the multiplicity here, is it even or odd? It's even. It's even. This multiplicity 2 is even. What about this multiplicity? This multiplicity 1 of 1 is odd, right? This one, x equals to negative 2 of multiplicity 1, it's odd, right? Multiplicity 1 is odd. Now, I like to, when I do my face intercepts, whenever the multiplicity is even, right? Evens are happy faces. They're very happy, okay? They're happy. That equals the even, or even multiplicities. When the multiplicity is odd, I always like to think of odd multiplicities as strange, right? They're strange. They like to cross over, right? They're strange. These are odd multiplicities. Okay, that's how I label my multiplicities. So in this case, it's even, right? Even. So if it's even, evens are happy, right? They're smiley faces, right? Odds, look at this one. How would you label this one? Huh? Odds are strange, right? Here, x equals to negative 2 of multiplicity 1. This multiplicity, what is it, even or odd? It's odd, and odds are also strange, right? So it crosses over, right? So I take my face here, and I ask myself, how many evens, how many odds do I have? Well, I have 2 odds here, and I have 1 even. So I just put them there for my memory's sake. Okay, 2 odds and 1 even, right? Remember, odd multiplicities, x's that are, and so you can see what's happening. Here we have 2 odds and 1 even. Now, the face multiplicities, when we find the face multiplicity, the x, they give us the what's happening. It tells us the behavior that's happening on the x-axis. Okay, let's say this is the y-axis. So what we're gonna do is look at whether or not an x is odd, or x's multiplicity is odd, or x's multiplicity is even. So what's happening here? We have x x is equal to 0, right? X is equal to 2, and x is equal to negative 2, 1, 2. And when we graph this function here, when we hit a 0 or an x-intercept, the multiplicities tell us whether or not they will. The multiplicities tell us the behavior of the function when they hit these x-intercepts. So, for example, remember I told you evens are happy; they're smiley faces. So, when the function hits 0, it's gonna make a happy face. It's gonna do like that, or do like this, right? Do upside down happy face. We don't know yet. We'll see. This will come together later. If the function is odd, in this case x, if the x-intercept has odd multiplicity, in this case x equals to negative 2 has a multiplicity of 1, so it's odd. When we hit negative 2, look, remember how I labeled it? It's gonna cross over. Odd multiplicities are strange, right? And if they're strange, things tend to cross over at there. Here, this one, x equals to 2. It's of multiplicity 1. That's odd. Remember, it's strange. If it's strange, it crosses over, right? But evens are happy faces. So whatever touches this, the x-intercepts of even that has even multiplicities, it will just make a happy face of a touch and turn. Okay. Now the last thing we need to know. Remember, we have our arms. We need to know our. So this will be step 1. Step 2 would get our teapot, which equals n minus 1, right? And step 3 would be to determine how repetitive the x-intercepts are. Sorry, I mean it will determine the face multiplicity, right? And determine whether or not they're even or odd at the x-intercepts, right? And determining whether or not they're even or odd will let us know whether or not the graph crosses or touches and turns around at those points. The last thing and final thing that we need to know is the y-intercept. Remember, intercept, if something is, intercept tells us that something is 0, and that something can't be that intercept that we're trying to find. So in this case, something is 0. It's not y. X is 0. And we're trying to find the y-intercept. This also can be expressed in this way. Since we have this function here, f at x equals to 2x to the 4th power minus 8x squared. We're going to make x 0. So f at 0. We're going to let x equal to 0. So f at 0 will be equal to 2x to the 4th power, it's over here, minus 8x squared. We're going to turn all of our x's into zeros. And remember, like I told you before, when you're changing an x to a given number, you're going to open up a parentheses around it. Okay? And you're going to solve for, try to solve it. 0 to the 4th power is 0, right? 0 times 2 is 0. Okay. 0 to the 2nd power is 0. 0 times 8 is 0. So our answer of f of 0 is equal to 0. So our y-intercept is the coordinate point. Our y-intercept is 0, and the coordinate point for the y-intercept is 0, 0. And f of 0 equals to 0. Okay, it's coordinate point. So that's the last thing we need to find out. I mean, there are other things that you can do. You can find out extra if the function is even, right, or odd. By testing for even, you can test for even, test even, test odd, and this will tell you if there's symmetry. Right? You just basically find out if f of negative x is equal to f of x. And then when you're testing for odd, you're going to find out if f of negative x is equal to negative f of x. So that's something extra you can do to find out if there's any symmetry. But we're not going to do that now. We're just going to use these 4 steps to graph our function. Okay, get up there. So we have, I'll erase this now because we already know what our y-intercept is. It's 0, right? And I'm going to use this space to graph. So we put it together, a polynomial function man, we know that the exponent is, the highest power is 4, right? So if we look at the arms of this function here, it should be facing this way, up, in quadrant 1. I mean quadrant 2. Quadrant 1. This is down. This is up. That's up. This is down. This is quadrant 3. Quadrant 3. So this is the down area, and this also quadrant 4 is also a down area. So since our power here, down here, look down here, is to the 4th power. 4th power is even. Our arms will be facing up, right? They will start off up here in this area, and then they'll start off up here, up left and up right. Okay. I kind of forgot something. We also have to make sure that it's positive. If it's positive, it's up, up. If it's negative, it will be in these 2 down reaches. But it's positive. You know, I automatically assume that you know. So it's up, up, right? It's up, up, and the power is 4. So 4 is even, so it's up, up. Okay, good. So we know that it's gonna end. It's gonna start here. It's gonna end here, right? Now we gotta tie into this thing. Is our face multiplicity. We know our face multiplicity. If we look here, our 2 odds and one even. We have a graph here. We have -1, -2. We have 0 here. We have +1, oops, +1, and +2. And one of the x-intercepts is x equals to 0, so we put that in. Another one is x is equal to 2. Another one is x equals to -3. I mean -2, -2, and +2. So let's start. We know we start up here. Let's go down to the first magnet point, which is -2. Don't take your pen off the paper. Don't take your pen off the paper. So we go to -2 and we go down. X is equal to -2 of multiplicity 1. The multiplicity is what? Odd. So guess what? It crosses over. It's strange. Odds are strange, so it crosses over, right? Now we have to go to the next magnet. Our next magnet is what? 0, right? So we go over to 0. Okay, boop, stop at 0. Don't take your pen off the paper, right? You go to 0 and you look down. And you see that x equals to 0 of multiplicity 2. 2 is even, isn't it? And when something's even, right, it makes a happy face. So it touches the magnet, like the happy face, and turns around. And in this case, it's an upside down happy face, right? It will touch here. It doesn't cross over. Don't cross over like that. It goes here and makes a happy face. A nice, smooth, curved, happy face. Just like this, but it's upside down. Then, now that we curved over, we touched and turned around, we have to go to the next magnet, which is what? 2. So we're going to go here to 2. Go here, stop here, look down. X equals to 2 of multiplicity 1. So the multiplicity is what? It's odd, isn't it? And odds are strange. They cross over, aren't they? Don't they? So we go here, we stop at this magnet, and look, we cross over. And now we're done. We have just graphed our first algebraic function, our algebraic polynomial function. I think we should try another one. Remember this process. First, find out what the arms are by determining what the highest power is, right? Then the teapot, then the face multiplicity, and lastly, the y-intercepts. And remember, if you want to determine the face multiplicity of its repetitiveness, you have to first factor. Okay? So let's try another one. Let's try something else. Let's try to graph x cubed plus x squared minus 2x. Let's try to graph this function. Okay. The first thing we're going to do, we need what? We left down. Sorry about that. We need what? We need the arms, don't we? We need the arms. The second thing we need to do is find our teapot, right? Which equals to n minus 1. So we find our arms, then we find our teapot, n minus 1, and then we find our face, right? We find our face multiplicity. We find our face. And we don't know if it crosses over here, how many times it crosses over, how many times it smiles. We don't know yet, but we're gonna find out. So we determine what our face is. So first, let's find out what the arms are. If our arms are, we look at the highest power. The highest power is 3, and it's positive, right? If nothing's there by default, it's positive. So our arms will be looking like this. It will be down in this region here, start here, and it's going to face up here. So our arms will look like this. Okay. The next thing we need to find out is our teapot. What is our teapot? Our teapot is going to be, remember, n minus 1. N minus 1 is 2. That's our teapot, 2. So there's going to be around 2 turning points, up to two turning points when we graph this function. We don't know exactly how many, but up to 2 turning points. Okay, and now that we're done with that, the next thing we need to do is determine our face multiplicity. So in order to do that, we have to factor. So let's factor this. X cubed plus x squared cubed plus x squared minus 2x. Let's factor it. And when we factor it, we get x squared plus x minus 2. And we can further factor this. X, oops, wrong way. X plus 2, x minus 1. Okay? I mean, you don't have to put a parenthesis here, but you can. It's up to you. You know, I don't like putting parentheses. Some textbooks put a parenthesis. It doesn't matter, okay? But there's always this, by default, an invisible 1 on top of all of these. Sometimes the books put 1, sometimes they don't. So you have to know that there's always an invisible 1 here, unless it's squared, right? In this case, it's not squared. So now what we got to do is take this out, take all these factors out, set them equal to 0. So take x out, set it equal to 0. Okay, and you gotta, after you set it equal to 0, you gotta look at what multiplicity it is. So x equals to 0 is of what multiplicity? It's of 1 multiplicity. It's repeated once. Okay, so it's of multiplicity 1. Okay, take this one out. X plus 2, set it equal to 0. X is equal to negative 2. And what's the multiplicity? 1 of multiplicity 1. And take this one out. X minus 1 equals to 0. Solve for x. X is equal to 1 of multiplicity 1. Okay, right? Of 1 multiplicity. So this multiplicity is what? Even or odd? It's odd. This multiplicity is odd. This multiplicity is also odd. So what's going to happen here is that it will cross over. This is odd, strange behavior. It will cross over. Will also cross over. So now we have our face. Go back here. We have how many odds? We have 3 odds. 3 odds will cross over. Great. So our function will cross over 3 times. Look at our face. It's weird, isn't it? Good. Now the last thing we need to know, right, is our y-intercept. Okay, so if something is an intercept, if we have an intercept, something is equal to 0. In this case, y is not equal to 0. It will be x. So we're gonna let x equal to 0. Okay, so we're gonna take f at x and change the x to 0 and put the function in. Q plus x squared minus 2x is the original function, right? So let's take our x's and change them into zeros. Okay. Okay. 0 cubed is 0. X, we gotta change this one to 0. 0. Right? 0 squared is 0. Minus 2 times 0 is 0. So our function at 0 is equal to 0. So the coordinate point is going to be 0, 0. Good. I'm going to erase this to save space. So our y-intercept is 0, and the coordinate point is 0, 0. Okay? So I think we can, with this information, we can graph our function. Okay. The first thing we're going to do is find out, put our our x-intercepts in. X is equal to 0, right? right there. X is equal to negative 2, 1, 2. X is equal to 1, 1. Okay. And now we're gonna graph it. Remember where our arms, our end behavior, how it begins and how it ends. Remember, it begins down and it ends up. So down, left, up, right. So let's start down in this area, anywhere. It doesn't have to be what we just marked. It could be anywhere. So we started down, and we're gonna go to our first magnet, which is our first point, and the first point is negative 2. And now we don't take our pencil off. We look down. Negative 2 is of what multiplicity? It's odd. So guess what? If it's odd, it crosses over, right? Crosses over, and it goes to the next magnet. Our next magnet is what? Our next magnet is 0. There it is, 0. Stop. X equals to 0 is of multiplicity 1, which is odd. So it's going to cross over as well. So we cross over, right? And we go to the next magnet. We go to the next magnet. Don't worry. We go to the next magnet, which is x is equal to 1, right? X is equal to 1 is of multiplicity 1. That's odd, so it's also going to cross over. Odds are strange. They cross over. So this is what our function is going to look like. Something like that, right? Now don't worry about these turning points here, right? We will never know exactly how far these turning points go up or down. I mean, they could go all the way up here. We don't know. They could go all the way down here. We don't know. And guess what? For algebraic purposes, we just don't care. So in algebra, turning points are totally useless. Well, not totally useless, but for graphing's sake, they're useless. So you can draw a Mickey Mouse in here. I don't care. As long as you go to this magnet, right, and cross over. You can draw a Mickey Mouse here. I don't care. As long as you go, well, you can't take your finger, you can't take your pencil off, but you get my point. You basically don't have to worry about how far they go. I mean, unless when you get your y-intercept, and your y-intercept was like 15, right? Then you would go to 1, 2, 3, 4, all the way to 15, right? You would just go all the way to 15. Okay, but in this case, our y-intercept was what? It was 0. So we just cross over, negative 2, go to the next magnet, which happens to be 0, right? And 0 is a multiplicity. 1 is odd, so it also crosses over. We go to the next magnet, which is 1, right? And 1 is of odd multiplicity, and we cross over because odds are strange, right? And we have this graph of this function. Let's try another one. Now, what if we're given this function here? We're given something like this. F of x is equal to x plus 2, right? And x minus 1 squared. Now remember, you have to determine the arms. In order to determine the arms, you have to find out what is the highest power up here, right? What is n? In this case, it's already factored for you. So guess what? In order to find out n, you have to unfactor it. Well, another way to determine n is by just using the power rule and doing this. So 2 times invisible 1 is 2, right? And then 1, there's an invisible 1 here. 1 times 1 is 1. And you add this together, and your highest power should be 3. Your n of this one, x equals to n, should be 3. Well, let me prove it to you so that you will see. Okay, we have this factor here, x plus 2, and look, we have x minus 1 all squared. So there's many ways you can unfactor this. Some people do it this way, x minus 1 times x minus 1, right? And then they go, x squared, and then minus x, and then minus x again, and then plus 1. I personally don't like to do it that way. I mean, I do it another way. That's kind of quicker. I just take the x, square it, so I have x squared, and then I take an imaginary 2, multiply 2 times x, right? And then, which is 2x, and then 2x times negative 1, which is negative 2x, right? And then negative 1 times negative 1. That's a quicker way to do it. Okay, and so we just got the same thing we just got. And you got to do the same thing again. You take your x, multiply it into x squared, x cubed. Take your x again, multiply it into negative 2x. So x times negative 2x is going to be negative 2x squared. Then do this again. Take your x, multiply it by 1. It will be plus 1. And then take your 2, multiply it into x squared. It's going to be plus 2x squared. And take your 2, multiply it into negative 2x. It's going to be equal to negative 4x. And take your 2 again, multiply into 1. It's going to be plus 2. Now try to put like bases, like terms together. Okay, so we have x cubed here. There's no other cubes here. Good. Cross that out. Underline it. There's a x squared here. Negative 2x squared. Any other squares? Yes, there's one right here. So it's positive 2x squared. Any other? Nope, no other squares. Okay, here's an x here. Any other x's? Yep, here's another x here. So we put those partners together. And then there's a constant of 2 here. There are no other constants, so we're done there. Now we're going to add and subtract like behaviors. There's x cubed here. Negative 2x squared plus 2x squared cancels out. With positive x minus 4x is going to be equal to 3x plus 2. Look what we got. Remember what I did here? We factored it, and sorry, it was already factored for us. X plus 2, right? Times parentheses x minus 1 all squared. And what I did, I took 2 times x to the first power is equal to 2 times 1 is 2. And here, there's an invisible 1 outside here. 1 times 1 is 1. So we add 2 and 1, we get 3. And 3 should have been the highest power. And look what we got. 3, indeed, is the highest power. So next time we get a factored form, we should automatically know, we should automatically do these steps. And instead of doing all this process that we just did, you can just take the shortcut and find out what the highest power is, so that you will know what the arm behavior is. And in this case, the arm behavior is odd, right? So the arm behavior would be going like, and it's positive. Look, it's positive too, right? Don't forget that it's not negative; it's positive. So the arm behavior would be down left here, up right. Okay. The next step, we have to determine our teapot. So down, up. Our teapot is n minus 1. 3 minus 1 is 2. So we have our arm behavior, down, up, down, up. We have our teapot. Our teapot is going to be 2, because 3 minus 1 is 2, right? And now we need to know our face, the faces of this thing, how it behaves on the x-axis. Does it behave odd, or does it behave even? Happy, or does it feel like crossing over things? Okay, look, it's already factored for us. You know, this would have been the original function they usually give to you. Then we have to factor it, but it's already the problem they gave us was already factored. X plus 2 to the first power times x minus 1 all squared. Okay, so what we got to do here, I'm going to erase this so that we have more space. We take this out. Now we're gonna find out what the face multiplicity is. Okay, take this out. Set x plus 2 equals to 0. Solve for x. X equal to negative 2. Okay, what's the multiplicity of x equals to negative 2? Look at it. It's 1, isn't it? It's 1. So it's of multiplicity 1. And we take this out, right? X, set it equal to 0. X minus 1 equals to 0. Solve for x. Right? That crosses out. X is equal to 1. Now, what's the multiplicity of x equals to 1? Look at it. Look at it. It's 2. The multiplicity is 2. So x equals to 1 is of it's repeated twice, isn't it? This one is repeated. X equals to negative 2 is repeated once. This one, x equals to 1. Its factor is repeated twice. So it's of multiplicity 2. Now this one, since it's of multiplicity 1, it's odd, right? This one, I mean, yeah, it's odd. Since this one is of multiplicity 2, it's even. If it's odd, remember, odds are strange. Odds like to cross over the x-axis. Evens, remember, they're happy. They're always smiling. They like to touch the point and turn around. Okay. Now the last thing we need to find out, remember, is the fourth step, which is the y-intercept. And remember, with intercepts, if something is 0, it won't be what we're trying to find, which is the y-intercept, the y. We're going to let x equal to 0. So we're going to take f at 0 and change all the x's to 0. Take our function here, change x to 0 to, you can take this one or the unfactored form of it. It doesn't matter. You'll get the same answer. 0, negative 1 to the second power. So this 0 plus 2 is going to be 2 times 0 minus 1 is going to be negative 1 squared. Negative 1 squared. Negative 1 squared is 1. And 2 is 2. 2 times 1 is 2. So when x is 0, right, y is going to be 2. So our x-intercept is 2. I mean, our y-intercept, our y-intercept is 2. And the point for this is, the point is 0. When x is 0, y is 2. Good. Now guess what? We can graph this. Let's graph it here. Okay. Take the graph here. So look at our points that we have. We have x is equal to negative 2, 1, 2, right? And we have x is equal to 1. So negative 2, and we have 1. And this time, look, our y-intercept is 2. So our point is 0, 1, 2. Okay? And let's graph it. Our arms are what? Our arms were odd, weren't they? So if it's odd, it's going to start down here and end up here somewhere, right? Down left, up right in this quadrant here. Lower quadrant, upper right quadrant. So we start here, down here, and we go up to the first magnet, the first point here, which is negative 2. X is equal to negative 2, which is of multiplicity 1, right? Of multiplicity 1. And that's odd. Odds are strange, right? So they do what? Odds cross over. They cross over. We go to the next point. Where's the next point here? Our next point is right here at the y-intercept, isn't it? All right, you go to the y-intercept. Well, guess what? We look. It's not here. It's here. So we just cross over. Okay, we cross over, and we're gonna go to the next magnet or next point, which is here. Okay, which is 1. Now x is equal to 1. It's of what multiplicity? 2 multiplicity, right? It's of 2 multiplicity, and that's even. Evens are happy, aren't they? It's even. Evens are happy. So guess what? We're here. We're gonna make a smiley face here. We don't cross over. We don't cross over, right? We're just gonna go here to 2, touch it, and make a happy face. Make that happy face. And guess what? We just grabbed another polynomial function. You guys are amazing. You should pat yourself on the back. You just grabbed another polynomial function. And we can try another one. Let's try, how about this one? Let's erase this. The more you practice, the more you will get better. And if you get better and get an A on your examination, I'm happy. Remember your 4 steps. You first find your arms, right? They can be facing up. Let's say they're facing up. Then you find your teapot, right? And -1. Then you find your face, right? And then you find whether or not when you factor out your function, whether or not it's going to be odd or even, right? And after that, you find your y-intercept. So let's find another function. I want to give you a hard one. So let's try this one. F at x is equal to -5x to the 4th power plus 10x to the 3rd power minus 5x to the 2nd power. Okay. So the first thing we're going to do is find our arms, right? Well, you can pause if you want. You can pause this and try graphing it yourself. So pause it. Okay, time's up. The first thing we're going to do is find our arms. Don't we? Find our arms. Woo-hoo. Right? And look at it. The highest power is even. It's even. And that tells us the arms are going to be facing up or down. We got to find out if it's positive or negative. The function is positive or negative. The function is negative. So while we have these arms here, that's going to be facing up, or in the same region, right? In the same quadrants, they're going to be facing down, right? It's going to be down left and down right in quadrant 4. Down left in quadrant 3, down right in quadrant 4. So they're going to be facing down. And the next thing we need to find out is the teapot. Our teapot is which is our turning points. How many times it's going to touch and turn around is n-1. N-1 is, the n is 4, so 4 minus 1 is 3. Our teapot is 3. So it's going to turn around. It's going to turn around sometimes up to 3 times. It doesn't have to be exactly 3. They can be less than 3. Okay, so up to 3 times. Now, the next step is to find our face. How many odds and evens are there going to be? Okay, in order to find our face, multiplicity, we have to factor this thing. So let's try to factor it. Let me erase this thing and try to factor it so we have more space here. So we have x squared here. Okay. And now we have to ask ourselves, can this be factored further? Okay, and we probably can. We can factor out what? The 5. So if you got this on the first trial, you can try to factor out other stuff. And here we can factor out 5, right? So let's factor out 5. Let's do it again. 5. So I'm going to factor out -5 and see what we get. So -5x squared. -5 would be positive. Oops. And this would be -10. This would be positive. Oops. Sorry. -2x. This would be positive 1. Okay. And you can check this by asking yourself the question, 5x squared times what equals to x to the fourth power? X squared indeed will equal to negative 5x squared times x squared. Does it equal to negative 5x fourth? Yep. Negative 5x squared times negative 2x does it equal to will it equal to positive 10x cubed? Yes. Negative 5x squared times 1 does it equal to negative 5x squared? Yes. It's good to do that because sometimes you make mistakes. So I'm going to move this up so we have more space at the bottom. Okay. Sorry about that. Good. Now, can we factor this further? And we can. It looks like this. Like that. One here. Now, this is a wonderful problem because look, you're gonna take this. Some of you guys will take this and try to set it equal to 0, right? Solve for x, right? Or in this case, you're gonna square root it. Now remember, when you square root it, you have to plus or minus both sides, and this equal to 0. Okay. I actually made a mistake here. Don't make that mistake. You have to set it equal to 0. Isolate the x, right? That will cross out. This will equal to 0, right? Because 0 over negative 5 is 0. So that's going to be 0. Now, you have x squared equals to 0. Now you're going to square root it. And when you square root both sides, the right side will be plus or minus 0. And you have x is equal to plus or minus 0. So, I just actually want to show you how to do it. So when you have other problems, you understand. So x will be equal to 0. This one. Here, x will be equal to 1. Set equal to 0, x will be equal to 1. Set this equal to 0. Yeah, x is equal to 1. Notice the problem. The problem that we have here. Both are equal to 1, and both of them are of multiplicity 1. When you have two factors, these are called factors. All three of these are called factors. We have two factors that are exactly the same, like this one, x minus 1 and x minus 1, right? Then you have to put them together. So let's put these together, right? Because they're twins. They look like each other. So x minus 1 squared, right? It's repeated, not once, but it's repeated twice, right? It's repeated twice. 1, 2. You have it twice. So we're gonna drag this down, do it over again. Minus 5 minus x squared. I mean negative 5x squared, right? That's another factor. Right? So let's solve for x. X is equal to 0. Now take this out. Oh, wait. Take this. X is equal to 0, right? What's the multiplicity? The multiplicity is what? It's 2, right? Of multiplicity 2. And 2's are evens. Well, just solve for this one. Take this out. Solve for set it equal to 0. Solve for x. X is equal to 1. What's the multiplicity? The multiplicity of this one is also 2. It's repeated twice. Look, it's repeated twice. So it's x equal to 1 is of multiplicity 2, and that's also even. Okay. So we have in our face 2 evens. Looks like that. The next thing we want to find out is the y-intercept. Put it up there. Stage 4, y-intercept. We're gonna set f. We're gonna let x equal to 0. F at 0 is equal to negative 5. 0 to the 4th power 10. 0 to the 3rd power minus 5. 0 to the 2nd power. And if we solve it, it's going to be equal to 0. So f at 0 is equal to 0. So our y-intercept is 0. The coordinate point is 0, 0. So we're done. We have all the points we need, right? And I'm going to try to graph it. I need the space. So I'm going to use this to graph it. Okay. Now, what are our x's? What are our x-intercepts? The first x-intercept is x equal to 0. Another one is x is equal to 1. 1. Let's make it farther out since we only have 2. 1. Let's do -1. Let's do -2. Okay, let's do -2, and so on. That's our x-axis. That's our y-axis. Okay. And before we graph it, we need to find out what our arms are. We know what our arms are is even, right? And the function is negative, so it's going to be down. It's going to be in the down in quadrant 3 and down in quadrant 4. So it's down here and down here. Now we need to start down here. Remember, we read graphs from left to right. So we're going to start from left. So we're going to graph it from left to right. So here, we start down here. We go to our first magnet, which is what? 0. We stop here. We ask ourselves, what is x equals to 0? What multiplicity is it? How many times is it repeated? It's repeated. It's of multiplicity 2. So guess what? It's even. And evens are what? Evens are happy. Right? Evens are happy. So guess what? This is up. It's gonna be, this one here will be upside down happy. Right? So we're not gonna cross over. Right? It's not odd. It's gonna touch it and turn around. Make that happy face. Make, right? And we have to go to the next magnet, which is what? 1, right? X is equal to 1. And if 1 is of even multiplicity, and evens are happy faces, they touch and turn around. So they touch here, it's going to touch here, and it's going to turn around. Okay, and face down. So look, we just graphed another polynomial function. And it looks just like this, doesn't it? Look at that. Pat yourself in the back, you just graphed another polynomial function. Now, I'm going to give you some polynomial functions that you can do on your own. Okay? Try to solve them. You can email me or just do it on your own. You can try this one. F of x is equal to x squared plus 4x plus 4. You can also try this one. F at x is equal to negative x cubed plus 4x squared. Try these two on your own and see what you come up with. And I'm going to give you the answer. I'm going to pause the video and you can put the answer yourself. Okay, that was your homework. Your homework was f of x equals to x squared plus 4x plus 4, right? You should have you shouldn't have gotten a graph like this, right? Like that. Should something like this. Does your graph look like this? Oh. So if you wanted to solve it, for those who didn't understand it or didn't know how to do it, you would factor this. You would get x plus 2 times x plus 2. Remember. X plus 2 is repeated twice, so you'll make it 1, right? So it'll be x plus 2 all squared, right? Then you would take this out, set it equal to 0, solve for x. X equals to -2 of multiplicity 2, okay? And so you have multiplicity 2, which is even, right? It's even, okay? So it's going to be a happy face when it touches this x-intercept of -2. And you get your y-intercept. F of 0 is equal to 4. Change all this, change all the x's to 0, and you'll come out with 4, right? So it should be up here. That's going to be your other point, the y-intercept. Then you graph it. You start from, since it's up in the quadrant 2 and up in quadrant 1. You start. We read the graph from left to right, so we graph it from left to right. So we start up. We go down to our magnet, or point, which is 2, -2. We make our happy face, right? Because the multiplicity of x equal to -2 is of multiplicity 2. It's repeated twice, and it's even, so it's a happy face. So we make that happy face, right? And we go up to our y coordinate, and we cross over it. Okay? Your other homework is f of x equals to negative x cubed plus y plus 4x squared. The graph should look like this. Okay, you factor it. I mean, you determine the highest power if it's even or odd, and you look at if the function is negative or positive. It's negative, so it's going to be, your arms will be look like this, right? Up in a quadrant 2, down in quadrant 4. Up, down. Turning points are 2, right? You factor it to determine your multiplicities. You factor it, x will be equal to 0 of multiplicity 2, right? That's even. You put that in. You do the same thing for this one. Set equal to 0. X will be equal to 4 of multiplicity 1, right? And multiplicity 1 is odd, so strange is going to cross over, right? So you have one odd, one even. And you find your y-intercept. If you change all these x's to 0, your y-intercept will be equal to 0, and the point will be 0, 0. You put your points in, 0 and 4, right? 4. And we know the graph is going to be start up and going to end down in quadrant 4. So we start up, we draw it, go to the first magnet, first point, which is 0, right? It's of multiplicity 2. It's happy, so it's not going to cross over. No way. It's going to touch and turn around. And you turn around, but we can go up. It's going to go up. It turns around. It's going to go to the next magnet. It's going to wear off and tire down and go to the next magnet, which is 4, right? 4. 4 is odd. It's going to cross over. There you go. So hopefully you got these answers correct. And hopefully you understand how to graph factorable polynomial functions. Okay? And that's how you use the polynomial function man. That's how you graph with the method of using the polynomial function man with the arms, your teapot, and your face. Okay? Good luck. Any questions, you can email me or write to me or blog me or whatever. Goodbye.